Okay everyone, let's take a look at Trig Functions Graph, Lesson 3. We're going to review a bit of what you did in previous lessons or previous grades, but also extend beyond that. So first of all, if you recall, trig ratios are basically the following. Okay, you probably remembered these by remembering the acronym SOHCAHTOA, okay, where sine theta, and these are all for right angle triangles, right? 90-degree triangles. Okay, so sine theta is basically SOH, so sine theta would be the opposite side over the hypotenuse side. Okay, and it's all relative to this angle here. Or it could be this angle, but relative to this angle, the opposite side would be there, and the hypotenuse is the side across from the right angle. So just reviewing that, this should all be fairly basic for everyone. Sine theta opposite over hypotenuse side. Cosine theta, okay, would be adjacent. See the A and the H? So adjacent side over hypotenuse. Okay, and tan theta is opposite over adjacent, so opposite over adjacent side. Okay, so yeah, that's how you can remember those ones. Now, reciprocal trig ratios are basically just that. They are the reciprocal of the original trig ratios. So if sine theta was opposite over hypotenuse, then cosecant, which is the reciprocal of sine, would be hypotenuse over opposite. You just simply flip that over. Cosine was adjacent over hypotenuse, so secant, the reciprocal function, would be hypotenuse over adjacent. Okay, and then finally tan, which was opposite over adjacent. If you do the reciprocal, you get cotangent, and that would be adjacent over opposite. Okay, good. Now, that's all review. What we're going to be doing in 30-1 is sort of relearning those ratios in terms of x, y, and r, because we need to now be looking at rotation angles, and it's not necessarily a nice triangle anymore. So let's stay in quadrant 1 basically, but redefine what sine theta, cos theta, tan theta, all of our 6 trig ratios, the primary ones, sine, cos, tan, and the reciprocal ones, what they would be. So sine, as you know, is opposite over hypotenuse. So opposite of this angle would be y over hypotenuse, which is r. Okay, cosine, adjacent to this angle, so x over the hypotenuse, which again is r. And then finally tan is opposite over adjacent, which would be y over x. Okay, easy enough to get the reciprocal functions. So the reciprocal of sine is cosecant, which we just take y over r and make it r over y. Okay, now you do not have to memorize that cosecant is the reciprocal of sine, but it sure helps because it's going to slow you down later if you don't. Good way to remember that is it's the opposite first letter, right? Sine, and then cosecant starts with the C. Cosine starts with a C, and the reciprocal function starts with an S. And then tan and cotan, they both have T's. That's a good way to remember that. Okay, so secant, reciprocal of cos, r over x. Cotangent, the reciprocal of tan, so x over y. Okay, now all of these you need to memorize. Okay, so the old SOHCAHTOA isn't going to work that well for you in this unit. So please make sure you memorize what sine, cos, tan, cosecant, secant, all that stuff is in terms of x, y, and r. Okay, let's look at the next page. Okay, this next topic, determining the sign of a trig ratio, I approach it a little differently than what the workbook does. So first of all, they talk in quadrant 1, so sine theta, y over r. Cos, let's fill this in, is x over r, and tan is y over x. Okay, and in the first quadrant, x, y, and r are all positive. But guess what? R is the distance from here to here on that terminal arm. That will always be positive. Okay, so r is always positive. So really, the only thing that changes the sign would be x and y. So when you're thinking about, what sign the trig function would be. Just worry about x and y really. Okay, so cosine in this quadrant, x is positive, r is always positive, so that turns into positive. Tan, y over x. Well, y is positive, x is positive, so y, positive over positive would give you positive. Okay, but again, just think about what quadrant you're in and whether x, which is related to cos, okay, r is always positive, and sine, which is related to y, which, again, r is always positive, what sign those would be. Okay, so over here, sine, which is y over r, and r is always positive, right? In quadrant 2, therefore, it depends on, sine theta depends on whether y is positive or negative. So it should be positive here, okay? Down in quadrant 3, y is negative, so sine would be negative. And over here in quadrant 4, y, again, would be negative, so sine would be negative as well. Okay, does that make sense? All right, let's try cosine. X over r, and r is always positive, so really it just depends on the sign of x. So if we're in quadrant 2, we've gone left, which means this is going to be a negative x, so cosine would be negative. Now, down in quadrant 3, again, we've gone left, and cosine depends on the sign of x, so again, cosine would be negative. Quadrant 4, we've gone to the right, so x would be positive, and again, cosine depends on x, so positive for cosine. Let's talk about tan. So tan uses a combination of y over x. So in quadrant 2, y is positive because we went up, and x is negative. So y over x is going to end up being negative, right? Negative y over positive x is going, or sorry, I got that the wrong way around. Positive y over negative x will give you negative tan theta. Okay, down in quadrant 3, tan, or the x is negative, the y is negative, so y over x is going to end up being negative over negative, which is positive. Quadrant 4, y over x, y is negative, x is positive, and the resulting tan is negative. Okay, so you can use cast rule if you want, but really after we finish going over the unit circle, it really won't be an issue. You'll remember what is positive and negative in what quadrant because it will all run together. So let's look at an example and how to put this to work. Okay, so example 2, determine without using technology, graphing calculator, whether the given trig ratios are positive or negative. So what we want to do first is figure out what quadrant we're in based on the angle given. So 280 degrees, if you recall, 270 is down here. So 280, a positive angle, would be just past 270. So we're in quadrant 4. Now sine, if you recall, is y over r. So y down here would be negative. R is always positive, so therefore this would be negative. Okay? And another way to write that is basically sine 280 is less than 0. That's another way to do that. Okay, let's look at tan of 7 pi over 6. Okay, so we did thinking in radians, so you should be able to figure out where that is. 7 pi over 6. So 6 over 6 would be pi, which is here. 7 over 6, a little bit more. So we're in quadrant 3. Okay, and over here, x is negative, y is negative, and tan is y over x, so negative over negative is going to be positive, okay? Or we could say tan is greater than 0, another way to say that. All right, cosine 10 pi over 3. All right, we've gone around more than once, so if we would go around once in terms of thirds, that would be 6 over 3, right? Otherwise known as 2 pi. So how much further? Well, 6 to get to 10 would be 4 thirds, 4 pi over 3. So let's see, this would be 3 thirds, and one more third would land us down here. So we're essentially in quadrant 3. Cos is related to x, because it's x over r is always positive. Cos over here would be negative, negative x. So the answer would be negative. All right. Why don't you guys try D, E, and F? A little bit tricky, but give it a shot, and then we'll check back and see if we both have the same answer. So please pause your video. Okay, so you might have gotten a little stuck on the reciprocal functions, but if you recall, cosecant 1 over sine. So if sine was y over r, then cosecant r over y. So it still depends on what y is. And in this quadrant, negative 225 degrees. Quadrant 2, y would be positive. Okay, and same idea with E and F. So check those answers, make sure we got the same thing. Negative for cotan of negative 13 pi over 6, make sure we ended up in the same quadrant. Okay, and 1000 degrees, that was a little tricky. We had to take away some full rotations by subtracting 360 a couple times, and then we are down to an angle of 280 degrees, the principal angle. And therefore that landed us in quadrant 4. All right, now you think you know how to use your calculator, but with these reciprocal trig functions, they can actually throw you a bit. So the idea is when you have cosecant, say, of something like 5 pi over 6, first of all, notice the angle. It's in radians, so make sure you're in radian mode. All right, and if it's in degrees, be in degree mode. All right, you're going to be switching back and forth all the time in this unit. Okay, so you would simply go on the calculator 1 divided by the sine of 5 pi over 6. Okay, never flip this angle inside the trig function. Never, ever, ever. Okay, cosecant is 1 over sine, not, 6 over 5 pi or something. That's ridiculous. So let's put this to work using the calculator, and you'll kind of see what I mean. Okay, so bring up your calculator, and we'll see if we can get some answers to these. You guys actually could probably go ahead and do A, B, and C, and D, actually, and then I'll help you with the reciprocal ones. But check out what mode you're in because it keeps flip-flopping back and forth, okay? So pause your video, get those numbers to 4 decimal places where necessary, okay? And we're good to go. Hey, I wanted to stop it here because I wanted to kind of make a mistake that probably many of you out there did. So we're in degree mode. We do sine 280, we get negative 0.9848. All good. Then we go tan 7 pi over 6. Now, you'll notice this number on your calculator, right? I didn't change my mode. So that's the kind of answer I would get. So let's, hopefully I realize that I didn't do that. Go back, change it to radian mode, and I quit out of there. Okay, now if I just hit enter again, it repeats the last command that I typed in. So let's hit enter, and there's the proper answer now by being in radian mode. So 0.5774. 0.5774. And just as a check, think about where you are, 7 pi over 6 down in quadrant 3, and that tan would be positive down there because negative y over negative x. Okay, let's continue on, do cos of 10 pi over 3, and the next one as well, which was sine of 90. Okay, and go ahead and write down those answers, okay? Pause your video, please. Okay, did you guys get negative 0.5 for C and 0.8940 for D? Now, how many were thinking that you needed to change this back into degrees because 90, right? You think that should be degrees? Well, believe it or not, there was no degree symbol here and it wasn't a mistake. So therefore you would assume that this is radians if there's no degree symbol. Okay, so make sure you're in radians. And then just type in sine of 90 degrees. All right, so now here's where it gets a little tricky. Cosecant. So first of all, we want to make sure we're in degree mode. Then we want cosecant, which is actually 1 over sine. Okay, now the angle kind of goes with that, so we want to find 1 over the sine of negative 225 degrees. So let's grab the calculator and do that. Okay, so we first of all want to change our mode to degree. There we go. Quit out of there. And we want to go 1 divided by sine of negative 225. And there we go. 1.414. 1.4142, I think it was, because we went to 4 decimal places. All right, good job. So we're going to finish those up. You guys we're almost out of the time, so finish those two and we'll give you the answers at the start of part 2 of this video, okay? So we'll see you then. Thanks.